me check. I'm sorry. Let me check. Oh, I think Miss Mutiara Lulu is not present yet. So maybe okay. We go to next presentation. The title of paper is the use of Google Classroom as ICT literacy to improve student collaboration skill in Revolution Industry 4.0. The presenter is Andreas Henuk. Mr. Andreas Henuk, I give the time.
Hello, thank you, Mr. Hadi. Hello.
Hello, yeah. I give you, we give you 10 minutes to present your work, and 5 minutes we will question and answer.
So, may I share screen?
Yeah. Wait a minute. The host will give you the access.
Okay, thank you. Good morning, everyone. Thanks for the time and chance given to me. Now I will present our research. The topic of our research is the use of Google Classroom as ICT literacy to improve students' collaboration skill in Revolution Industry 4.0. Introduction. The first is the rapid development of information technology in the current era of globalization. Vietnam 2019, the integration of ICT in teaching and learning. ASA 2016, the national curriculum requires teachers to use ICT in the classroom. Ramadan 2019, ICT literacy is needed in education. Enuk 2019, the use of Google Classroom as multimedia learning. Ramat 2019 and Enuk 2020, Google Classroom as a virtual class. Gunawan 2019. Method. The research method used in this study is qualitative descriptive method using questionnaires as research instruments. The instrument used was validated using product moment, and the reliability was using KR20. Data analysis using Likert scale to measure people's opinions and perceptions. Results and discussions. There are two tables. The first to measure ability students to use of Google Class, and the second to measure students' collaboration skills. The fifth table indicator ability to use Google Class. There are some points. The first is able to access and use Google Classroom through Android or iOS and PC. Able to use the service features available in Google Classroom in general. Able to use Class assignment, we choose to do assignments given by lectures and collect in the form of PDF files, link material in the form of videos, PPT or simulation that can be shared with friends and lecturers, able to collaborate with lecturers and friends in discussing online to answer questions and get feedback and be able to provide feedback. And the last is able to use Google Classroom responsibly by not sharing things that violate the professions. So the average percentage is 90%. The data in the table besides shows that the ability of students to use Google Classroom as ICT literacy is included in the excellent category. This means the students are already proficient using Google Classroom. The second table, collaboration skill standards. There are three standards. The first is demonstrate the ability to work effectively and respectfully with diverse groups. And the second is practice flexibly and willingly to help in making the compromise needed to achieve common goals. And the last is assume shared responsibility for collaborative work and the value of individual contributions made by each team member. There are 5 indicators. The first is work productively, showing respect, compromise, share responsibility, everyone contribute. So the average of collaboration skill standard is 79%. Conclusion, based on the data and discussion above, it can be concluded that the use of Google Classroom adds students' insights into information and communication technology with a score of 90%. This means that physics education students have excellent ICT literacy skills. Students work productively, so respect, compromise, and take responsibility as a collaborative characteristic of the 4.0 industrial revolution in collaborating with their friends and lecturers through Google Class with a score of 79%. This is the meaning of very good participation. Overall, the average score is 84.5%. It can be inferred that the use of Google Classroom as ICT literacy can enhance students' collaboration skill in the era of the Industrial Revolution 4.0. That's all. Thank you.
Okay, thank you very much, Mr. Andreas Henu. Now we open the question and answer session. All participants, I invite you to give a comment or question to Mr. Andres Enoch about his presentation. At the time I'll give to you, and please raise hand. Use the reaction icon, so the host can identify you, and the host will give you the microphone. I think unmute the microphone. There is any question? Oh, Mr. Nanang, I think. Mr. Nanang, please, uh, uh, I give you the microphone.
Thank you so much, Mr. Hadi.
Okay.
You can hear me?
Yeah.
Okay. I have a question to Mr. Andreas. But what is the reasoning where you use Google Classroom? Are there something reasoning where you use this application? And in your research, are there some comparison with other application? We know that in online system for lecture, there are some the other application. So what is the reasoning, the main reasoning where you use Google Classroom? Thank you so much.
Okay, thank you very much, Mr. Nanang. I think we can you can answer directly. So please, Mr. Andreas.
Okay, thanks for the question. I'm sorry, I have problem with my PC, so I have been come back. The first I use Google Classroom because Google Classroom is friendly user for students, and I think it is simple. So I use Google Classroom as a ICT literacy to measure students' collaboration skill. Thank you.
Okay, thank you. And there is another question, or there is any comment from Mr. Nanang? Is enough the answer?
Maybe Mr. Andreas can give me information where do you do your research? It's in some area, such area, or maybe from the research can generally to all of region in Indonesia.
So there is any specific area, Mr. Andre, about
Okay,
your
thanks for feedback. I use this research in Universitas Musamus, Papua. So I think Google Classroom is friendly for student here. So the student here is a specific student for another area in Indonesia. So I think Google Classroom is
so
better to use in here.
so the research conduct in the undergraduate student
Yes.
in Papua. Okay.
Yes.
Okay. Okay. There is another question. Please raise hand. You know? Oh, okay. Okay. So because the time already 50 minutes, we go to next presentation. Thank you very much. We give applause to Mr. Andreas Hanu.
Okay. Thank you, Mr. Adi.
Okay. Next presentation is Mr. Siswoyo. He will present the paper with title Teaching High School Physics Using Pet Interactive Simulation. The time I'll give to Mr. Siswoyo 10 minutes. And after that, we will start question and answer 5 minutes. Okay. Please, Mr. Siswoyo.
Good afternoon, ladies and gentlemen.
Good afternoon.
All the participants of Science and Mathematics International Conference UNG 2002. Today, I would like to present my paper, And the title is Teaching High School Physics Using PET Interactive Simulation. Many research have been conducted using PET, and using PET allows students to explore all the phenomena and like the scientists do. Some research says that the use of PET media has an effect on student understanding of the electric photo effect, and even handbook have made to use how photoelectric effect. PET simulation enable teacher to develop learning model with using PET. Virtual simulation with PET are often compared to real experiment, and the results are equal advantage. Research show that the use of PET can improve student critical thinking and also trigger cognitive thinking about physics concept. PET can improve student understanding, motivation, and also increase student activities and learning outcomes. Research has also shown the use of PET as virtual experience media and improve cognitive aspect. Our focus in this research is to find the answer how students analyze relationship between force and change in energy kinetic in moving object in horizontal fields. And the second, analyze the relationship between force and potential energy and potential energy change in object moving in incline. The third, analyzing the relationship between non-conservative force with mechanical energy. And the fourth, evaluating suitable graph on image of relationship between positive object with energy. In this study, students conduct two virtual experiments. The first is RAM, and the second energy skate park. In this case, you can play the RAM using PET and allow students to manipulate all the variables using PET. And the second, students play the game and then how to demonstrate energy kinetic and potential in each position, for example, in A, B, and C. And the result of the first, we asked the student about the object moving in the horizontal field, supporting by F, and there is a friction force. So by using PET, student can demonstrate how they apply the force and set the friction force, and then by the table, they can understand how many value in this case. So in this possible plan, we have the answer that the second answer is apply. And the second is the object moving downward from the A to B. So using PET, student can demonstrate how they apply and release the object from the A to B. So the using PET is allows students to understanding the process, and then they know about the energy and velocity on each position. And that's third question. Students play the game by using the RAM. They put the object, for example, the human here in B, and release, and the human moving downwards from A to B until C. And then from C to B and A, and then etc. And just move on, etc. So if I ask student which the graphic, appropriate graphic using pad, they know about the example here. And the fourth, we change the position of the pad. There are many positions. And ask student what kind of the graphic are related to this movement from A, B, C, D, and A. So the conclusions said that students, the first, they analyze relationship between force and change and kinetic in moving from downward. And the second, the student can analyze relationship between force and potential energy and potential energy change in object moving in incline. And the third, the student can analyze relationship between non-conservative force with mechanical energy. And the fourth, the student can evaluate the possibility graph or image of relation between position on objects. That's all my operation. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Siswoyo. So now I open the question and answer session. Please raise hand if you want any question or comment. Pak Andreas enggak? Oh, sorry, Pak Andreas.
Okay, thanks for the time and chance given to me. Now I want to ask Mr. Sisoyo, can you give your main reason why you choose pet simulation? Thank you.
Yeah, thank you for Andreas. I think it's pet is well known already in the world. As you know, is about 150 experiments are available in PET. There are so many research conducted by PET or experiment or developing media. So why I choose the PET? I think it's the PET is very easy and user friendly. So student can install the pad from the gadget or laptop. So, and based on my experiment, student can access the pad using their handphone. So it's very easy to conduct the research using pad. The many research said that the pad is supporting physics learning by many activities. Then student can manipulate many variable and can demonstrate some phenomena in related to the physics. Thank you.
Okay. Thank you, Mr. Sisoyo. Is enough, Mr. Andreas?
Yeah, I think it's enough. Thank you.
Okay. There is a question from Mr. Mr. Sajito. He asked about in the figure energy part. Can student answer if we ask question? What curve is shown by a curve as this figure? What the physics parameter is shown by that curve?
Yeah, in this experiment, PET can show the kinetic energy, potential energy, and a total energy. So if you change the position, the objects, so the PET can show how energy or potential energy and kinetic energy are in show in the object. So many position can demonstrate by the graphic. So it's very easy to show in the student the relation between mechanical energy, potential energy, and kinetic energy. It is very easy. Thank you.
Okay, thank you very much, Mr. Sisoyo. There is another question. Oh, Mr. Sarjito, you want I
Yes.
give you? Yeah.
Yes, thank you. I just clarify my question.
Okay.
If we use the graph like that, yeah, we show to the student, and then we ask after we make a simulation, we ask to the student what physics parameter is shown by that curve shown in the figure. Can they answer directly?
Yeah.
Thank you.
So I already told about before, there are many parameters. The first, the highest of the position of the object. As we know, the highest position or the position in the object are related to the movement of the object. The movement of the objects are related to the kinetic energy. And when the object moves from above to the downward, so you can say the relationship between the speed of the object, and so it's demonstrate the kinetic energy. When the object reach the position, so the PET can demonstrate how many potential energy. So it is related within mechanical energy, kinetic energy, and potential energy. Thank you.
Okay, thank you, Mr. Sisoyo. Because of time, so thank you very much for the presentation, Mr. Sisoyo. We give applause to Mr. Sisoyo. Maybe in the next, you can directly using corresponding author to ask more detail. Okay, we go to next presented. Next presentation is from Mr. Sahal Fawais. The title of paper is Developing E-Procedural Scaffolding to Enhancing Scientific Reasoning Skill of the Senior High School Student, graded Show Height Button. To Mr. Sahal Fawais, the time I give, please.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Today I will present our research. Our title research is developing a procedural scaffolding to enhancing scientific reasoning skills of senior high school students, graded so or hide button. Our team is me, Sahal Faiz, Kusnul Nur Hidayah, and Supriyono Kos Handayanto. We are from Universitas Negeri Malang. Okay. All students, before entering class, they have a different prior knowledge. And they have a different learning style, like visual, auditory, write and write, and kinesthetic. And the solution is a teacher can scaffold for every student. Teacher can use various learning media to scaffold every student with hers or himself, but it's not effective because if teacher scaffold one by one, student can need more and more time, and it's not effective for learning achievement or learning outcome of student. And then beside that, scientific reasoning skill is always needed in science education. This skill is defense understanding concept, learning achievement, critical thinking skill, and problem solving skills. But until now, national NGIS 2015 said that on 2009 until 2015 there is no significant increasing about scientific reasoning skill in world. And Mariana on 2018 said that much student at the concrete operational level. So the solution is we can use E or web scaffolding or computer scaffolding to enhancing scientific reasoning skill. The last research is from Sofiatun. She success to increase in mathematical reasoning skill, and Rashid she success to in all collaborative learning in traffic light learning and on elementary school, and who he successful to increase reasoning skill student in biology inquiry learning. So the solution is we use a procedural scaffolding with grade so high button. What is the advantage? Student can access this web in class or in our home, so not need curtain classroom. And about the feedback, with direct feedback and more accurate and more reliable. So the student can improve learning motivation to study, especially in physics. And this web learning can assist in achieving an excellent learning and assessment achievement. Our method use AD model. The first stage is analysis. We did two analysis: is field analysis and need analysis. Field analysis, we observe and interview for student and teacher about e-learning in school, and we get literature to learning about e-learning and the advantage of e-learning is especially in scaffolding. and we design after that on storyboard, and we develop with a learning use model. We buy a domain and hosting to that, and after that, after we development, we give to expert. There are two experts in our research and give a rating for our product. And this the last stage is limited try and quasi experiment design. For our result, for our product in web. So there is two button, show and hide of a procedural stage to student. So if he or she get difficult, we can seek or he can access the second button. It's more easy for him or her or his. The result of product validation, so that the product is categorized into very visible with percentage 85.5%. Then the suggestion given by validators are as follow: the let's write words need to revise and repair the error button. And from our research in limited try was conducted on the product towards 75 students. The average is a very practical, 78.29%. And for quasi experiment design, we use one group pre-post test design with 24 students in 11th grade in senior high school, and we use a scientific listening test with reliability 0.797 with 26 items, and the result is our data is not normally distributed. So we use a Wilcoxon Signing Right test, and the result is the assumed significancy with two tail is 0.003. So the result is say that there is differ from pre and post test of scientific listening skills student. Use is procedural scaffolding. And the conclusion is the product of a procedural scaffolding which has been developed consists of the electronic worksheet, the learning video, Blackbook video conference, the PowerPoint, and ebook. And the result of expert validation, the limited try, so that the assessment media product computer is categorized into very visible and very practical. And the comparison of pre and post test of scientific risk and skills is differ with using procedural scaffolding with graded so height or button inflate topic. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Sahal Fawais. Now I open the question answer session. So please raise your hand and asking something and all comment, please. There is any question? Oh, there is a question from Mr. Siswoyo. Do you want Mr. Siswoyo, please? Yeah,
thank you. I want to ask you the state of the AD. Usually, the researchers conduct the research about development object is only step until developed. So what kind of activities related the implementation, and what kind of activities you conduct related to the evaluation process? Thank you.
Mr. Sal, please.
Okay, thank you for this question. On this implementation stage, I was try a limited try to 75 student, and we give Google form to record the responses on how to use the easiest or difficult to use that e-learning. And for after that we revise from the suggestion from a teacher or student about the content of e-learning, and after that we we conduct a quasi experiment for one class pre-post like I present before. That's all.
What kind of the evaluation? As you know, the evaluation can be conducted only when all the material is already fixed after validation and the implementation. So what kind of evaluation of this project?
Okay, thank you. Based of suggest from validator and suggestion from student, we repair a error button, the first evaluation, and the second evaluation is almost of student is difficult to log in for e-learning. I don't know why. And then after that we try to give a tutorial video for student to make it easy.
Okay, because the time, so maybe next discussion more intensive with the corresponding author. So thank you very much for your presentation, Mr. Salva Wais, and we give applause to Mr. Salva Wais. Now we go to the next presenter. Next presenter is Halim. The title is Application of GeoAlgebra Media in Teaching the Concept of Particle Kinematic in 1 dimension and 2 dimension. So the time I give to Mr. Halim, please.
Assalamu alaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Good
wabarakatuh.
afternoon, ladies and gentlemen. Now, I want to talk about of my work, the impact of virtual life worksheet on student learning outcome in sound wave material. Introductions. During the COVID-19 pandemic, basic learning process both in higher education and high school used a lot computer media, including using Edu Plaza media to reduce misconception, a media tracker to improve critical thinking skill, using a learning media to develop diagnostic tests, use of internet media to increase understanding of concept, use of smartphones to increase student interest in learning, and GLE's model based on computer simulation to improve understanding of physical concept. The use of computer media is that there are applications that run online and there are also run offline. But There are also applications that can be run in both conditions, online and also offline. One of it the PET simulation media. The PET simulation media is relatively very large, including the development student workshop of PET simulation, the development of practicum model with PET simulation, comparison of the result of manual practicum and virtual practicum with PET simulation, the use PET simulation with inquiry approach, the use of generative learning model using lab virtual, the application of NHT learning model by utilizing lab virtual, and the use PET simulation to improve mastering of physical concepts. Based on the results above of this study, it can be understood that the use PET simulation media so far have been widely used in an auxiliary media to develop other media of also used simulation as the main objective media. Based on the data found in the field or in the sample school, and also some advantages of simulation media from very recent results, it's become very important and urgent to develop student worksheets for use in virtual practicum activity through the PET simulation media. One of the goals developed by the SW Lab Virtual is to improve student learning outcome in the sample school. Besides that, the PET simulations is also very interesting and very easy to use. This application can be used online or offline so that they can use it anywhere then anytime. Research methods. The research approach used in this study is a research and development (R&D) approach. Development research, in this case, the student research development, uses the AG model. There is analysis, design, development, implementations, and evaluations. This is diagrams AG model. First, the analysis. What is the analysis? Systematic explorations of the way things are and the way things should be, different in performance gap. Designs. If analysis identifies a performance gap, design phase will outlet the performance objective. Developed using the information gatherings in analysis and design phase, performance solutions is created. Implements. This step include deliver of performance solutions. Evaluated. Measurement of how well the performance solution achieve the objective. Risk methods validity of student workshop SW. The SW validator is done by 2 experts of IT for display and 2 physics content expert of physics. Each validator given a display validation sheet and content validation sheet. Pilot tests or implementation phases have been done with pre-experimented method, or there are only one class to try. before the pilot test, students are demonstrated or socialized the use of SW Lab virtual version of technique. To get effectiveness data of product before testing, before pilot tests, it is first given the pre-test. On after pilot test, we given post-test to students. The result of an discussion. This is a table of pre-test and post-test. If we see in this table, only a student, a third student, he not complete individual competence, and to one student to 12 student, all complex and individual competence. This is a recapitulation of teacher skill. Teacher skill using SW Live virtual fed simulations. First, preliminary or introduction. If we see from two observers one, he see preliminary step, all activity is very good, and then core activity, direct and access presentation of his group is very good, only directing student to discuss group to study SW if lack of good. Let's go. I'm observer 2, same observer 1, the step of preliminary all very good, and then core activity goods, and then closing activity I think very good, means 3.5. And the last classroom situation closing this good. All activity observer 1, observer 2, 3 we get 3.38, mean very good. And then the response of students, we asked the student about 7 item. All student he have respond as very good. All student happy with learning uses SW Lab virtual simulation, and then all students say that they were interested in this KBM, kegiatan belajar mengajar. They wanted to apply the use SW Lab virtual to other learning, special science learning using live virtual face simulation make them love physics lessons. Learning using the live virtual simulation can assist them in understanding material and answering questions, and they can understand sounds wave material after learning by using live virtual situation. Conclusion: happy to get positive response to use SW which have innovative value in it. The use of SW Lab virtual simulations in the sample school can improve student learning outcome. Management of learning by teacher using SW Lab virtual simulation fed also efforts that have impact on student activity or on student grades. Student states they happy with teaching learning activity using SW Lab virtual simulations, and assumption learning using this model include new learning, and they are interested in joining the GBN. Thank you for your attention.
Okay, thank you very much, Mr. Halim, for your presentation. Now the question answer session. I give the time to all participants. If any question, please raise hand. There is any question? Oh, okay. If no question, thank you very much for your presentation, Mr. Halim. There is a comment from Mr. Sarjito. He said about the AD. He thinks it's very difficult to develop something before the implementation process is done. He thinks. Okay, now we go to next percentage. The next percentage is Mr. Parno. Mr. Parno will present the paper with title The Increase of Problem-Solving Skill of Students Through STEM Integrated Experiential Learning with a Formative Assessment. To the Mr. Parno, the time I'll give. Please, Mr. Parno.
Good morning, ladies and gentlemen. We are from Physics Department, Universitas Negeri Malang. Our name is Parno Estiani Nur and Eni Latifah. Our article have titled The Increase of Problem-Solving Skill of Students Through STEM Integrated Experiential Learning with Formative Assessment. Background. Someone who is successful in solving problems is an indicator that he has a good conceptual understanding. However, students' ability to solve problems is still low. There are several studies were conducted to resolve the low problem-solving skill. However, some of the previous studies didn't facilitate students to construct their knowledge through their own experience in the collaborative learning with structured assessment. Collaborative-based learning is also needed as one of the aims of the 21st century skill. This type of learning has a basis that learning is not only one's own, but also based on the other people experience and actively involve themselves in the learning process. Based on that, STEM approach is considered appropriate to be applied to improve students' problem-solving skill. This is supported by the statement of Dr. et al. From 2016. We state that problem solving is a complex process in daily life and important to learn in the STEM field. Besides STEM approach, we need a model that can support the approach in providing direct experiment for students. Prior studies state that experiential learning integrated with STEM can improve the mastery concept and problem solving skill of DHH students. Assessment has the power of innovate learning. The right type of assessment to be integrated with experiential learning is formative assessment. There are collaborative activities and formative assessment which are very appropriate with the 21st century skill needed. The study aims to increase student problem-solving skills through STEM integrated experiential learning with formative assessment. Method. The type of this research was mixed method with embedded experimental design. Experiential learning has three syntax. The STEM learning activities, according to Sutapan Yuyong, has 7 stakes. Formative assessment was done through collaborative activities, keep big feedback, and empower students to self-assess. The first syntax in experiential learning, namely concrete experience, was inserted with the identification of social issue state. The second syntax, which is reflective observation, was inserted the identification of potential solution state. In this state, there are collaborative activities and giving feedback. The third syntax, abstract conceptualization, was inserted with knowledge necessity and decision-making state. There were collaborative activities, giving feedback, and self-assessment, and this syntax. The last syntax, namely active experimentation, was inserted with prototype of product development, solutions test and evaluation, and decision socialization and completion stage. In this stage, the teacher also activates students in collaborative activities, giving feedback and self-assessment. The problem-solving skill instrument tests were 6 essay questions with reliability of 0.766. The quantitative data were analyzed with Wilcoxon, Lange test, and Keene and effect size, while the qualitative data from the answer of essay questions and learning video recording were analyzed by coding, data reduction, and conclusion. Research and discussion. Pre-test and post-test were significantly different. This is according to Marshall stated that there is an increase in problem-solving skill in DHH student by implementing STEM integrated experiential learning. There are gain in medium category and effect size in strong category. This is according to research by Koff. Koff stated that the experimental learning can provide 2 exponents in experience for students, namely conceptual understanding and innovative learning experience. Conceptual understanding gained through experiential learning can affect students' ability to solve problems. On the other hand, according to Colomer et al., the inclusion of experiential learning cycle stage in formative assessment makes student experience increased learning reflection and long information store. There are increase in the average score of student aspect, useful description, physics approach, specific application of physics, mathematical procedural and logical progress. The physical approach is lower than the useful description stage. This is consistent with study conducted by Molyastuti et al., which she stated that students only have partial knowledge on the topic, so that sometimes they are only successful in useful description aspect, but not in other aspects. The percentage of students and the spatial application process physics aspect has increased. In the spatial application principle stage, many students wrote the equations correctly based on the analysis they did on the picture or sketch they made at the useful description stage. This proves that the information presented qualitatively, such as pictures and sketches, is very useful in the problem-solving process. Conclusion. Based on this research and discussion, there are few conclusions. Students have gained significant increase in student problem-solving skills within keen and medium category and effect size and strong enough category. Students have improved indicator of useful description, physical approach, spatial application of physics, and logical progression. The result of the analysis of the various answer questions show that the pretest most students were still difficult to determine variable symbols, physics units, and tend to use the plug and chuck approach. But in the post-test students were able to determine variable, make some representation, and use the right approach and formula. Therefore, STEM integrated experiential learning with formative assessment can increase student problem-solving skill and can be used in learning. Thank you.
Ladies and gentlemen.
Okay, thank you very much, Mr. Parno. Now I open the question and answer session. Please raise your hand to if you want to ask or give a comment. I give the time, please. If there is any question or comment.
Okay, I want to ask you.
Oh, okay. Please, Mr. Siswoyo.
Okay, thank you. As we know, STEM is related to the science, technology, engineering, and mathematics. So there is a interdiscipline topic. So what is the specific objective you conduct when you state that the STEM are related to the physics, especially component with the engineering or mathematics or technology? Thank you.
Okay, thank you, Mr. Siswoyo. Can you answer the question, Mr. Parno, please?
Oke, pakai bahasa Indonesia boleh?
Boleh, Pak, boleh.
Ya, terima kasih Pak Siswoyo. Jadi ini bersama mahasiswa itu membahas tentang fluida statis ya. Nah, jadi di sana itu engineering-nya itu membuat dua produk ini, yaitu jembatan hidrolik dan jembatan apung. Jadi misalnya jembatan hidrolik itu permasalahan utamanya adalah misalnya ada di sana disajikan begini, ada perahu, misalnya video gitu, perahu mau menyeberang sungai, tetapi di situ ada jembatan. Nah, padahal perahu itu harus lewat jembatan itu gitu. Apa kira-kira solusinya? Nah, gitu. Itu yang jembatan hidrolik. Kalau jembatan apung, yang satu lagi produknya itu jembatan apung gitu. Nah, jembatan apung ini masalahnya ya bagaimana membuat di situ daerah itu sering banjir gitu. Bagaimana membuat jembatan sehingga jembatan itu tidak terganggu oleh banjir di situ, yang di sungai di situ. Nah, kira-kira di situ engineering-nya. Terima kasih. Saya kira itu sudah cukup untuk saya. Terima kasih.
Okay, thank you very much, Mr. Parno. There is is it enough, Mr. Siswoyo? The answer?
Yes, okay.
Okay. There is another question or comment, please. There is any question? Please raise hand or give a chat. If no question, we give applause to Mr. Farno. Thank you very much, Mr. Farno, for your presentation. Now we go to the next presenter. Next presenter is Mr. Sarjito. The title of his paper is Determining of Object Temperature Influenced by Ambient Temperature as a Solution of the Law of Cooling or Heating Rates. The time I give to Mr. Sarjito to present. Please, Mr. Sarjito.
Ladies and gentlemen, all audiences of this conference, may we introduce ourselves. We, Sarjito and Nani Yoningsih from Politeknik Negeri Bandung, shall present our paper with the title of Determination of Object Temperature Influenced by Ambient Temperature as a Solution of the Law of Cooling or Heating Rates. This comes from our research in physics. As a background of our research, first, thermophysics experiments are generally characterized by temperature measurements of experiment object. Second, the influence of the ambient temperature, which is higher or lower than the object temperature, during experiment is significant enough. Third, we need to make correction to the temperature of measurement results using calculation based on Newton's law of the rate of cooling or heating. Fourth, the ambient temperature can be constant, also can be varies against time. Our methodology of the research is, first, we make model of the condition of cooling or heating of objects which is influenced by ambient temperature. Second, we analyze mathematically the model to find solution, first for a constant environmental temperature, second for temperature of the environment that changes against time. After we get the solution, we test this solution of the model to the experimental data, which is obtained through the practice of physics experiments for the mechanical heat equivalence module in our physics laboratory. The result, the condition of the body or object temperature, which is influenced by ambient temperature, can be modeled by this differential equation. We call it Newton's law. The derivative of temperature to time equals to K multiplied by L minus T. K is constant, L is ambient temperature, and T is body or object temperature. From this equal differential, for this differential equation, we have a solution for constant ambient temperature. If the temperature of the body greater than the temperature of ambient environment, we have the solution is like this. Body temperatures equals ambient temperature plus A times E to the power of minus Kt. T is time, A and K as constant. And for body temperature less than ambient temperature, we have the solution like this. Body temperature equals ambient temperature minus A times E to the power of minus Kt. Also T is time, A and K are constant. From this model, we apply to the data of our experiment to check the significance of our model. So we have, from the data, we make visualization with this graph between temperature to time. The green one, the green point, are the temperature of the body real temperature measuring by thermometer, and the gray one is theoretical temperature, which are calculated by this model. So it can be seen from this graph that our model is significant enough because the temperature of our theoretical calculation almost same or equals to the temperature of our measured temperature by thermometer. After that, we apply this model to calculate the heat which is generated in our calorimeter we use in our experiment. The heat equals to heat capacity multiplied by difference of temperature. The difference of temperature were calculated by the difference between final temperature and initial temperature if we give the mechanical work. But here we make correction to the temperature, to each temperature, which is measured by thermometer. TU is measured temperature, and TU key is measured temperature with correction after we make correction by this model. So we have here delta T1 and delta T2, and the difference of temperature which is applied to this formula to calculate the heat is delta Ts equals to delta T1 plus delta T2. After that, we make comparison, we make ratio between Q and W. W is mechanical work, which is given to the calorimeter, and Q is heat, which is generated by the calorimeter. So, theoretically, the ratio should be 1. The value of this ratio should be 1 according to the law of conservation energy. Before correction, we have the ratio experimental data is like this, 0.914. But after we make correction with this model, we have the ratio is 0.932. So our model make a better result, give a better result for this ratio because this value much closer to the theoretical value is 1. For ambient temperature changes against time, we have the model is almost same with the before because we have differential equation, but L, ambient temperature, is a function of time, not constant. This differential equation have a solution like this to have the temperature of the object temperature equals to e to the power of minus kt times integral k times e to the power of kt times L dt. So with the special case, we take the data of ambient temperature from another paper, which is varies to time as a function, sinusoid function like this. We have the solution is like this. See, the last term of our solution is exponential, negative exponential to the time. So it is like damping term. We make visualization of this model, of this solution. The red one is temperature, which is the object temperature, which is using this solution, and the blue one is ambient temperature. We can see after steady state condition, after a long time, that the temperature of the object much closer to the ambient temperature, even they are same value. The conclusion of our research is First, if the temperature of an object is different from the ambient temperature, then over time, there will be changes in the temperature of objects that adjust to the ambience, both for a constant ambient temperature and changing ambient temperature over time. The temperature changes of objects are more dominated by the exponential function of the time. Before we called it damping term. When there is another energy conversion, like mechanical work, correction should be done for measured temperature that are already different from the ambient temperature. When the ambient temperature changes to time within a long time, then the object temperature will be almost equal or equal to the ambient temperature. Okay, that is our presentation. We hope that it will be useful for all of us. Thank you very much.
Okay, thank you very much, Mr. Sarjito, for your presentation. Now, I open the question-answer session. Mr. Nanang, you want to ask something, Mr. Nanang?
Okay, Mr. Adi.
Yeah, please.
Thank you for the presentation. I want to know about the ambient temperature can influence the system. If as your method can be used in extreme ambient temperature, we know that if the difference of the temperature, the object and the surrounding area is very big or very high, it is how much it can be tolerated in your method or system. Thank you.
Okay, thank you, Mr. Nanang. Can you answer, Mr. Sarjito, please?
Yes, thank you. This model, based on Newton's law, is more dominated by, we know that there are three kind of heat transfer, and this model is dominated by radiation. So we have to know the relation between the model of Newton's law and radiation of Stefan Boltzmann. So if the difference of temperature is very high, it means that the constant K, it depends on the radiation parameter, also high. So it is, of course, the influence is big enough. I mean, big influence is the time is very short. So the gradient of the curve is very sharp. That's the answer, my answer.
Okay. Okay, Ms. Nanang, it is enough? The
Yes,
answer?
I think. Thank you so much.
Okay, there is another question. Please raise your hand if you want to ask something. Maybe just my curious, Mr. Sarjito.
Yes.
So, what kind of calorimeter did you use? So
Metal.
you can, what kind of calorimeter?
Metal calorimeter.
Metal. Oh, okay.
Yes.
There is any specific ratio
Aluminum.
standard? Yeah, standard ratio. So 0.9 it's a specific standard from the company.
No, I mean the ratio between Q and W should be 1, according to the law of energy conservation. We give
based on theoretical.
Yeah, theoretical. So experimental, we have 0.93. Yeah.
Okay, thank you. Okay, there's another question. Okay. Okay, thank you very much, Mr. Sarjito, for your presentation. We give applause to Mr. Sarjito.
Thank you very much.
Okay, now we want okay. there is sorry, there is a message from the committee. Please participant make a presency using the link in the chat room. Please the committee remind me to absent the press participant. So please fill the presentation in the link in the chat room, please. Okay, thank you very much. Now we go to next presenter. Next presenter is Miss Tiara Sari. Miss Tiara Sari will present the paper with title Developing Dialogue Argumentation Worksheet to Improve Student Understanding Ability and Argumentation Ability in a Static Fluid Topic. The time I give to Mr. Tiara Sari. Hello, Miss Tiara Sari. There is do you present here? Do you Miss Tiara Sari? Oh, Miss Tiara Sari. Maybe she didn't attend this chat this session, this parallel session. So okay, we skip. Now we go to next presenter. Next presenter is Mr. Fauzi Bakri. Mr. Fauzi Bakri will present the paper with title Textbook with Augmented Reality Technology, Improve Critical Thinking Skill in Elastic Concept. The time I give to Mr. Fauzi Bakri. Okay, I'm sorry. I think I don't see also Mr. Fauzi Bakri. So maybe this is the end of this session. Before I close this parallel session, can I ask you to open your video? We will do a photo session. Can I invite you to open your video and we do photo session for the documentation, and maybe we will upload this in our website in this parallel session. Okay. Mr. Okay, already? Please open your video. This photo session. Okay, ready? Yeah, ready? Ready? This is okay. Cheese. 1, 2, 3. Okay. One more. Wait. Okay. 1, 2, 3. Okay. One more. Okay. 1, 2, 3. Cheers. Okay. That's all. Thank you very much for your attend in this parallel session. Thank you very much for your attention. See you in another conference or another meeting. Thank you very much. And I close this with a statement, keep a research, keep hungry, and stay fully. Thank you very much.
Okay, thank you,
Wassalamualaikum
Sue.
warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam
Waalaikumsalam
warahmatullahi.
warahmatullahi wabarakatuh.